So we will talk about some very basic networking stuff so that we would do you guys know where they will send us the slide? This will be available on the resource page. So resource page on the BESA website is where you will get, if you see with the QR code in the middle of the slide, if I'm highlighting it here, scan this QR code, that is will take you to the BESA program page, and on the left side there will be a resource section where these slides would be made available to you, so you would have everything there. Okay, good. Now the networking tracks idea is to give you basics of networking. We will today focus on very generic networking concept, and then we will enhance that networking knowledge in AWS world. But I wanted to bring everyone on the same page because people may not have that kind of networking knowledge, and that's why we are talking from the very basics here. Okay, and if you have any suggestion for topics to include, something we can do differently, let us know, and we would be happy to accommodate that. Shouldn't be a problem at all. Let's go ahead and talk about the networking track. I'll start by asking a question here. So let's say this is a old country setup. You could see a king here, and that king would obviously have a lot of subject who is ruling. Then this king wants to send some message to this subject that, hey, this year there is some issue, maybe I paid a lot of money to build my new castle again, and that's why I am going to raise more taxes, so higher taxes would be there. Now, obviously, it is old time. There was no mobile or WhatsApp group or a Slack channel, so there was no way of communicating these basic things to you. So, what was King would be doing? King would have this message being sent through a communicator or a messenger. So that message would be handed over by King to this messenger. This messenger will go to the subject and will announce, hey, this time you have to pay 10% more taxes because King has built a new place for them. Right. Now, my question here is that in this analogy or in this example, who actually represents a network? Who is you would call a network is? Who is representing a network here? Messenger, road, all of them, messenger. Okay, the road, messenger, pathway is the network. Messenger, yes, that you are on, a lot of you are on right track. Messenger is not the network. Let me go ahead and give my interpretation, and obviously you could have different interpretation in this case. So King is your server. A server wants to send some message, right? So that message has to be sent by a server. So King is your server. And then you have subject. Subject are basically client who are going to receive it. So Parul, this subject would be considered as the client who are receiving the information. Server sending something, client receiving the information. The message itself is the data we want to forward. Whatever I want to share with someone, that data is my message itself, and the messenger here is the protocol who is carrying that data from a server to the destination or to my subject or client, which could be TCP IP or something else. So yes, they have different aspect of working. I agree on that. This road is what represents a network here. The path on which your protocol would travel, from which your data would flow, by which your server and client would communicate, that is your network. So you may be thinking, hey, Ashish is going to help me build roads. Could be a road like this, yes, or it could be a road like this. So it depends on what is happening here. I'll explain about protocol Jaya in a minute. We'll talk about that. So idea is we want to set up a path, and on that path, like in this road, I may have a small car going, maybe a biker, maybe a cyclist, maybe a huge 40-foot container truck going on. But once we have built a path, it can be used by lots and lots of services and resources. So that's what we are trying to build. Now, if I give you my definition of what a network feels to me, I would say network is a collection of devices that can communicate together. right? And if I give a little more generic business definition on that, I would say it is a fabric that ties business applications together. Like we are currently using network for seeing this WebEx from my home. I'm broadcasting that goes on the network to my service provider, goes to the StreamYard server, and then goes to Twitch. From Twitch, it is being distributed to your network, and you are watching it. So it is all tying up all the business applications together. That is your network, right? Now, if I go with dictionary definition, in computing, what we are referencing here is a protocol. What is the protocol? Protocol are rules determining the format and transmission of the data. Protocol tells you that how this message has to be sent. Let me again take an example so that you could relate to this protocol mechanism. Let's say you have to send a letter. Now you want to send someone letter. I am not referencing that I would go manually and physically present this letter to someone. I want to use some method of delivering this letter to someone, and that is where my protocol is. If you are in UK, you would be using Royal Mail as a service, which is our postal department in UK, who would send a letter from one place to another place. So there would be a process to follow. The process would be something like this. I have to write a letter. I have to put it into an envelope, write an address on it, put some stamp on it that will be paying to the service provider, and then I have to drop that into a letterbox. This is a Royal Mail protocol if you want to send a letter, right? There is a sequence I am following. There are some specific steps I have to follow, right? Now, I still want to deliver a letter, but what if instead of Royal Mail, I say I would use a courier company like DHL or USPS or maybe some other DHL company or other thing? What I should do in that case? Now, I still have to have my write a letter, which is my data. I may put it into envelope, which I'm putting like a layer of security on top of it. Now, they do not require, like, let's say if I'm referencing DHL, maybe they do not require me to buy a stamp, but they would say go online, buy a barcode and put that barcode on the message. And they give me facility that you can schedule a pickup. So I don't have to walk up to the post box. I would have a scheduled pickup and somebody would come up and pick up the letter, give me a information about receipt, and then I would hand over my letter. Once I have done that, my responsibility is done. Now it becomes that service provider's responsibility to get this letter from point A to point B, and they would be using different methods for that. So what I am seeing here is one type of method of communication, another type of method of communication, that is your protocol. So protocol is a way by which we package our information in such a way that it can be delivered from one network or one server to client or between client. It all depends. So that is what a protocol is. So protocol, if I go with standard definition, it is a standard of communication. You would be using packaging, addressing, payment, getting on the network. In case of Royal Mail, payment was done through a stamp you purchased. Here it was into DHL case, it was an online payment you have done. Getting package on the network, in Royal Mail you have to drop that packet, and in case of your DHL you had it collected from the home. So that is a same thing which we are seeing here. So we need to have packaging done, addressing done, payment sorted, and get that package to network. And obviously I can't say, hey, I bought the stamp and now I want my DHL to pick up. No, it won't work. So they won't interoperate. If two devices has to communicate, they would need the same type of protocol to be used with them. So that's how a protocol would work. So computers on a network must agree upon a common protocol in order to communicate. Let's go ahead and see how this protocol has come into existence. I hope everyone is following along and understanding the basics of communication. Now, in very early days, I'm talking about 1960s, 1970s, that time, every manufacturer, let's say this is manufacturer X, manufacturer Y, manufacturer Z, they would develop their own networking solution. And let's say this speaks a language ABC, this speaks a language PQR, and this speaks a language, let's say STU. Obviously, this is not a way where we can communicate with each of them. And everyone was developing things on their own method. There were isolatedly being developed. There were no interoperability. There were lots of complication in communication. So somebody has to take a lead and then say, okay, we would use one common language of communication. Like I am using English language here as a communication mechanism. Is it my native language? Answer is no. But as most people use English and understand English, I am utilizing it so that I could communicate better. If I just use my own native tongue, probably some of you may understand, some of you may not. So that's why we need to agree on a common standard, and somebody has to take a lead. Open system interconnection, OSI model, that is where all the standard were made, and then we started following. So organization called ISO, standard organization, international standard organization, they developed a theoretical model. I am saying it again. It is a theoretical model which says how your services should communicate, how your networking devices should communicate, and they started calling it as a OSI model. It is a reference model, right? It is a reference which most of the service provider follow, and then they build their devices, their solution, their application, so that they can all interconnect and communicate with each other. So that is called OSI model, open system interconnection model. And this is a theoretical model. It is not put into practical action. We will talk about how practical things are implemented. But the OSI model is designed as a 7-layer model. Intention was we want to reduce complexity, we want to standardize interface, modular design so a company can focus on one layer and ensure interoperability. And this is made up of these 7 layers of communication: physical layer, data link, network, and all. And every layer is doing its own specific work so that communication can happen. And this theoretical model says that I have to send my data through application layer. It would go from this whole layered approach to physical layer, and then it will be actually transmitted to the destination device. So this is a OSI model. Now, why this is important? Lots of time when you discuss things, people would say, hey, I need a layer 3 filtering, or I need a application layer filtering. So if you see this thing, application layer is here, which is our top layer, or that is also referred as layer 7. So this is where your applications would interact with each other. They would provide access to the application. So if I'm, let's say, I'm using MS Word and I am storing my data into a remote drive. MS Word doesn't know how to access a remote network, but because this packages data and send it to another layer, they can then get these things sorted. So I drop my letter into Royal Mail mailbox, but I do not know what happens behind the scene, how they pick up, how do they sorting, how they package it again. That is not my headache. I just drop it. And same thing, application would just send information to application layer, and then the whole process would kick in, and then your data would be moved from one place to another place through a method called encapsulation and decapsulation. So we'll see that in a minute. So OSI is a theoretical model. We expect this to be a way of communication, but it is not practically implemented. We will see what is practically implemented in a minute. Any questions here? Any doubts? Any confusion so far? Now, how it works, probably most of you remember this, right? I was very scared about all these things. Capsules means I thought that it is made up of plastic, and if I swallow it, it would stuck in my throat and I'll die. So that was a fear I had. Obviously, it was not plastic, it looked like plastic. But what this was, that some drugs or some medicine which could not be put into a tablet format or maybe into a solid form, it has to be powdered form. And how I eat it, I would eat it through this capsule. Right. So if I have to take that medicine, this has been put together into a layer, and that layer would dissolve in my body, and then medical drug would then go ahead and do the work it is expected to do. So same thing happens in our communication too. This process is called encapsulation and decapsulation. Now let's consider there is a source host and there is a destination they want to talk. If they want to communicate, what would happen? Think like in the memory of this host, a theoretical model is created, and in the memory of this host, also a theoretical OSI model is created. 7 layers in the source side, 7 layer on the destination side, and now I start sending my data. So once I have my data, the data would follow the process like this. It would be sent from application layer, reach to the physical layer of this device, which is source, travel over the physical network, reach to the destination physical network, and then move upward and then reach to the destination. This is the whole process which is happening, how these things are working. So let's go ahead and how it will work. Uh, you will never forget encapsulation now. I agree on that. And that's why I use analogy so that the concept would stick in your mind and you will never forget it. So let's see this thing. So same way like we were packaging some medical thing into the capsule, we would do encapsulation here. V means the system. System would take the data from application layer, put a header. Header is the additional information. Like if you have written a letter to someone, this letter has to be put it into an envelope, and on that envelope you would add to and from information. That is a header you are putting on top of it. So same way, as soon as the data goes from application layer to presentation layer, they would be putting a header. Like if I have taken a DHL some for to send my letter, they would put a barcode on my letter so that they would track it. So that is the same thing, additional information, which is a header added to my data by presentation layer. And then my data would go to the session layer. Now, for session layer, this whole thing has become a data. And then they would add their own letter, right? So let's say DHL picked up the letter from me. They have added a barcode to scan it. And let's say this letter has to go to New York from London. Obviously, they won't send one letter. They would package it into a bigger box. And then inside that, there will be a lot of letters. This bigger box will be again packaged maybe into a bigger shipping container. And in that, there will be multiple boxes. So as you could see, your letter is there, but it is going through different layers of protection, shipped it, and then nobody will deliver a container to my destination. They would deliver the letter again. So it has to be opened, remove the things, and then get the letter at the destination and deliver it. That is the process of encapsulation and decapsulation. Very simple. So for every layer, the top layer is sending data or receiving data, and every layer adds its own header. Like you are applying for something and your application is going through multiple approval cycle, and every approver adds his or her own data on top of it. That is exactly what we are trying to do here. So every layer will keep on adding extra information, which is basically then making your packet larger, and through this you will be able to send information. Yes, payload per header and each layer. And one more thing here, that these layers are expected to communicate only to their peers. So transport layer will take data from session or forward data to session, but it won't directly talk to presentation or application. So everyone will talk to their just above or below layer, but not a random communication. So frames will come at later part. So what is happening here, that this data is being packaged and they use a different wording for that, right? So the wording here, that this is all here data, and then it becomes your segment. Here it is called a segment. In a network layer, this one is called a packet, and on data link layer, that data is referred as a frame. So these are the three ways to identify that information. If somebody is saying segment, probably they are referring to a transport layer. If somebody is saying packet, which is the most commonly used word, we use that for network world. And when I'm saying frame, frame is mostly on a data link layer, which actually puts like a header and footer information both, and then it get translated. So that is how your data would go from one layer to the source to destination. And once it reaches to destination, what would happen? That package would keep on opening up. So physical layer got information from physical layer, it would remove the physical header information here, whatever it was been added, and then forward the remaining thing here. This layer will read information, remove its header, and keep on passing that data up to destination. So at the end, what will happen, whatever you actually transferred would be reached to the destination, and every layer will add or subtract the header and then deliver the data to the destination, right? Right. So frames are on the data link layer. That package is referred as a frame. And then there is application layer, it is data. Transport layer, it is called segment. And the network layer, it is called packet. Right. Uh, all right. Move forward. Now, This was a theoretical model, and it was very good in terms of being understanding. But when they started implementing, they realized that hey, there are a lot of complication in implementation part. So they took the concept of it, but instead of your application, let's say you have interview process of Amazon, which goes through, let's say, 7 round of interview, which can be very complicated. So we say now, hey, let's go ahead and combine some of the things like this. So what happened here? The theoretical OSI model was taken, and its a practical implementation is what we all use, is called a TCP/IP model. And TCP/IP, the name is given because there are two prominent protocol. One of them is TCP and another is IP, and that's why this model is called TCP/IP. But there are more protocols working behind the scene to make your communication possible. So if I see this thing, my application presentation session layer work is squeezed into application layer of TCP/IP model. Transport layer work is still transport, and the renamed network layer to internet layer, and then data link and physical has become a network interface layer. So that's how your TCP/IP model is there, and this is the actual practical implementation. Right now, whatever we are communicating, this is all happening through TCP/IP. All the internet is where TCP/IP works. In early days, there were more protocols. Maybe I'm going into history now. IPX, SPX was one protocol that was by Novell. Then Apple had their Apple Talk as a protocol that was also there, but again didn't survive. Then we had Net Bias protocol from Microsoft, but they were not scalable enough as TCP/IP. So overall, what happened that these all faded away, and only prominent model we have is TCP/IP, and which is because there are two, sorry, main component. One is TCP and second is IP, allowing you to communicate, right? But there are more protocol. Let's say I'm using DNS, or I am using SMTP, or I am using SSH. So these are all operating on application layer, and then TCP IP provide that kind of communication for it. All right, good. Let's move forward and let's see what else. So this communication happen, and we need some better ways to address the things. So we had to come up with a way where computers communicate. So let's talk about the binary choice. Binary is the 0 and 1. Now let's see why we had to come up with binary, to give you a basic idea. Now, we humans, we count in a decimal number system, right? We always count like, hey, I have to get this much of $10,000 to someone, or I want to get maybe $100 to someone, or maybe I want to buy 10 of the bananas, or I want to buy 1 kg of something. So we always talk in decimal system. Whatever numbers we make up, the base of those numbers is 10 digits, 0 to 9. These 10 digits helps me in making whatever you have created as a number. My question to you is, why humans have selected decimal as a number system? Why not 9 digits? Why not 7 digit? Why not 100 digits? Why we selected 10 as a digit number for our numbering system? Any random thoughts here? Why 10? Why not 11? Why not 9? You nailed it. You nailed it. Exactly. How we have learned numbering. We learned numbering on fingers, right? The simplest one. Yes, exactly. So we all count on numbers. We have 10 fingers, and that's why we have come up with a system, because we can count it on finger. How you learned all counting? Probably all counted on fingers, and then we have learned how to calculate things. So that's how things happen. Now, computer do not use this 10 finger. They do not have hands and fingers. So that will not work for them, right? So computer use binary. Binary is 1 or 0. So now my question is, why computer use binary? Why not something else? Sorry, why binary for computer? Why it makes sense for you them to use binary number system? Why binary? Yeah, humans on and off. Yes, exactly. Like a switch, electricity. Exactly, exactly. So a bulb can have a position like a on or off, right? Either there would be light or no light on that. Signals work like that, right? Then you may have a wire which may have current or not current. right? So that is again one or zero kind of a situation. You may have a switch which may have on and off, and basically your electronic devices are all made up of these type of small simpler devices. But as we have so many of them compacted, it looks very complicated. But behind the scene, everything is one and zero, and in our world, one is on and zero is off, and that's how a binary has become the way of delivering the content to the computer, and that's how we will utilize it. All right. I hope everyone is following along. Now, let's give some more calculation bits here, bits and bytes. So when we are talking about bits here, the bits is basically made up of one single box. Either it would have a value of 0 or 1. Think like you build a box, and in that box, either you could stuff 0 or you could stuff 1, but nothing beyond it. So that is a bit. A single addressable possible value is a bit. Now calculating bits by bits will be very complicated, and that's why we have combined them together into 8 bits, which is a byte, and that is which every box now can have 0 or 1 as a value, and there is a weightage of every value. Like, so when I'm saying I'm writing 55315, so I would read it 55,315, because this digit is 1, this is 10, this is 100, this is 1000, and this is 10,000. So our weightage is coming because of the 10 to the power, because this digit can have up to 10 values. So this is 10 to the power 0, this is 10 to the power 1, and this will be 10 to the power 4 similarly. In case of binary, the base is 2, so the value would be on based on 2's power. So this is my place value, and here I would be having a value of 2 to the power 0, 1, 2, 3, 4, and up to this 2 to the power 7 into 1 byte. And if you do the math here, this placeholder value will come out to be 128, 64, 32, 16, 8, 4, 2, 1. That will be total making up the actual digits. So if I take this box and put the minimum value 0, so minimum number I could address in a byte is 0. Maximum number I could address will be 255, which will be made up of 128, 64, 32, and all these things. So that's how we represent the numbers in binary format. All right. I hope everyone is following along. I'll take 5 more minutes to give you an idea that how easily you can convert these. You won't need this calculation every day, but understanding this calculation will help you in your routing and switching logic. You would understand better that how routing actually works if you have this idea. Right. Let me go to one more analogy to explain that how easily you could convert these things in understand the format. Let's say we are talking about a startup. This is a company called BetterBox. There's a red and blue startup company, and red and blue, they invented a type of box which has become like very popular, whatever it is inside, and we should have a shop. They started a shop to sell it. Now Mr. Red is on the counter. He is taking the order. Blue is working in warehouse, and Blue keeps on bringing up the package. So if a customer comes and says, "Hey, I need 120 packages," then this blue person has to go 120 time to the warehouse and keep on bringing one box each time, and that is very very complicated. Customer would come with different demands, and that would make the life of Mr. Blue a hell. So what we want a better approach for that. Is there a better way? Answer is yes. What Blue did, instead of bringing one box, he has created bigger boxes of these sizes. Should this be remembered for networking exam? Not directly. You do not see. Is any exam going to ask your ABCD knowledge? Obviously, no. But if you do not know ABCD, would you be able to learn anything else? Answer is no there also. So we are talking here about very basics. And then once you have this sorted, it will help you to understand subnetting. It will help you to understand different routing aspects. So that is the same thing we are trying to do here. Just to bring everyone on the same page, it is not going to be asked in an exam. Nobody will ask you to convert binary and decimal. But when you are creating summary routes, and maybe you are creating routing table entries, this knowledge would help you. So what Blue did, Blue has packaged all the stuff in this format that one box is 128 items, 128 box packed in 6432. And let's say now our order comes, hey, we need 40 boxes to be delivered. What Blue would do calculation to make 40 what I need 32 plus 8. So what I have to do now, I have to just take two boxes instead of taking 40 boxes one by one, and that made his life easier. Let's implement this thing into the actual world, how it would be working, right? So that what I have just shown you is a IP address. So it's an IP address. What we have to do for every device to communicate, we have to have a unique identifier for them on the network, and that unique identifier is your IP address. Like we all use mobile, our mobile number is our unique identifier. No two mobile in the world can have same number because it has to be unique. And similarly, devices on a public network cannot have same IP address. I'm saying it here, public network. So I cannot have the same IP address on a public network for two different devices. So we will identify these devices by IP addresses. IP addresses are made up of 32 bits. And these 32 bits are divided like this: 8 bit, 8, 8, 8, and 8. And that would help you to create a number. If I put everything as a zero, the minimum number I would get will be 0, 0, 0, 0, 0. And if I go to the maximum, it will be all one. That will be 255, 255, 255 here. And that's why we are getting this information, right? So if I have to now, let's say, convert some things into binary, how I would do that? Let's say I have a decimal number here, 40. I want it to convert to be binary. I will write down this 128 series at the top. And for 40, I have to take 32. And I have to take what else? I have to take 8. So I would keep everything else as 0, but only keep 1 on the digit I want to keep. And that would be the equivalent of binary number for 40. This is what my binary number is. Right. So that is the first number. I want 128 to be identified. What I would do in that case? First number 128, remaining nothing required. So I will keep all zeros, and that would bring up to my 128. And similarly, if I have to keep 19, I would take 16, 2 and 1. Only those bits will be set as 1, and remaining else would be all zeros. And that's how I would keep on identifying different aspect of my application. Right. So hopefully this was easy and you understood little bit of information here, just very basics. And we will then go ahead and talk about more interesting stuff on networking. Let me quickly show you that what we have planned. And this is a tentative agenda. We are open for suggestions. If you have something which we can bring it here to improve your information, let us know, right? So we talked about cloud today. We talked about IP addressing, and then we will talk about activity in a minute. Next week, I'll talk about S3. We'll get introduced to VPC and then EC2 and then activities and all. So this is the agenda. This is on the website. You could go ahead, and as I'm here, if you see this additional resources link here on the very left, if you click on that, it will tell you the last session's resources. Like we did two sessions so far. One was in 2022 in May and then September. So these are all listed here. And if I, let's say, go inside, you would find what was the recording link, technical track information, PDF of that, additional resources which we want you to choose. So that will all be posted in a week's time here. Obviously, we do this thing in our private time. So please bear in mind that we do not have any SLA. Everything is voluntarily basis. Everyone helps behind the scene based on the time they get. So it may not be on the very next day. It may take little time, but yeah, recording would be available on Twitch for the same week. And afterward, it would be then available on YouTube. All right. So I hope everyone has enjoyed. Let us know if there are any feedback, anything which we can do to help you better. And if you like this training, if you have and if you learned something new, have you clicked something and you learned something first time, probably share this information on LinkedIn so that more people would be aware and more people would know how we can learn things easily. Technology doesn't need to be complicated. Technology can be explained in simpler fashion, and that is what we are trying to do here, right? So anything which you liked, take a screenshot from the Twitch afterwards, put it on LinkedIn, tag us, tag BASA program so that everyone would know that how we can get started and how cloud journey can be easy, not should be complicated. All right. So thanks everyone. I hope I have not bored you and you have learned something new.